Hey everybody, this question is from the 2019 free response exam, and this is number 3. This is on the no calculator section. So there is a graph of f, and it says the continuous function f is defined on the closed interval -6 to 5. The figure above shows a portion of the graph of f consisting of 2 line segments and a quarter of a circle centered at the point 5, 3. It is known that the point 3, 3 minus root 5 is on the graph of f. And part A says if the area under the curve from -6 to 5 is 7, find the value of the area under the curve from -6 to -2. Show the work that leads to your answer. So obviously, those are definite integrals, and I was just interpreting that as the area under the curve because that's one way to evaluate that definite integral. So this question is about integral properties, and I'm going to just draw a really general graph here to remind you on how we could do this. So they gave you the area from -6 to 5. I'm going to just draw some random graph here, and they're asking us the area from -6 to -2. So they gave you this area that is in yellow, and they're asking you to find this area from -6 to -2. So we're going to write a statement on how to get the area from -6 to -2. And this would be a good time to pause and see if you can come up with how you would get the area from -6 to -2 if you were starting with the area that was given from -6 to 5. So because you know the area from -6 to 5, but you only want the area from -6 to -2, this is going to be a subtraction problem. So in order to get the area from -6 to -2, you can start with the whole thing, which is in yellow, the area from -6 to 5, and then you would take out the area from -2 to 5. So it's the idea that you're starting with this big piece, which is in yellow, and you're taking out the area from -2 to 5, and that's going to leave you with that area from -6 to -2. All right, so I'm going to, I guess I'll just rewrite this. And then the area from -6 to 5 was given as 7. So I'm just going to replace that integral with a 7. And then here's the work that you have to do. You have to find the area from -2 to 5 in order to evaluate that integral. So I'm going to look at the area from -2 to 5 of the graph they gave me. And when I first did this problem, I found this area, and then I found this area, and then I found this area of that triangle, and then I found this area. And that was not wrong. I got the right answer because I had to find the area from -2 to 5. But when I looked at it again, and I think you will appreciate this shortcut, I realized that this area and this area are going to actually cancel because you have a positive and a negative, and it's the same shape. And the same thing happens right here, this little triangle and this little triangle. Those cancel out as well. You have a negative and a positive, the same shape, those will cancel out. So the yellow is going to become 0, that purple is going to become 0, and we're still trying to find this area from -2 to 5. So far I'm at 0 and 0. But then I get to this shape, which is a trapezoid, and then this shape, which is a little strange, and we're going to look at that in a second. So first, let's do these areas up here. For the trapezoid, it's going to be 1/2 the height, B1 and B2, and your height is here on the x-axis, so that is a 1, and then your bases are shooting up the y-axis, so that would be 1 and 3. So 1/2 of 4 is 2, and that is your trapezoid area. I'm going to write that down here. Okay, so still trying to do that area from -2 to 5. We have the yellows that are canceling, the purples that are canceling. We have the blue trapezoid, which is the area of 2. And then they give you this challenge here. So they want you to get this area, which is not a geometric shape that we can find the area of with a formula. So what you have to do instead, you can pause if you want to see if you can figure that out. You have to do more subtraction. So in order to get that yellow area, you would start with the area of that square that I just drew and subtract out the area of the quarter circle. This is using the idea that the integral represents the area from or between the curve and the x-axis. So that's how I know we want that yellow area and not the actual area of the quarter circle. We knew that our circle had a center at 5, 3. That was given. And so the area of the square is going to be 1, 2, 3. It's a 3 by 3. So the area of the square is 9. And then we're taking out the area of that quarter circle. So I am finding this right now. Okay, so the area of that circle is going to be pi. The radius from the center to the edge is 1, 2, 3. So pi radius squared, and I'm dividing it by 4 because it is a quarter of a circle. So that leaves me with 9 minus 9 pi over 4. So that yellow area, again, I started with the area of the entire square that I drew, took out the area of the quarter circle, and that left me with that yellow area, 9 minus 9 pi over 4. So going back here to our statement, the area from -2 to 5, we had our canceled out triangles, our other canceled out triangles, our trapezoid, which had an area of 2, and then the area of that yellow shading was 9 minus 9 pi over 4. From the very beginning of the question, we knew that we were going to get this area from -6 to -2 by starting with the whole piece, which was 7, and taking out the area from -2 to 5. So we have our subtraction, which is going to be distributed, and then that area from -2 to 5 was the trapezoid 2, and that yellow shaded area, which was 9 minus 9 pi over 4. Remember that you are allowed to stop now. You don't have to simplify at all if you don't want to. So you can be completely done with the problem now. If you wanted to simplify, you would distribute the minus sign. And that would be 5 minus 9, which is -4, plus 9 pi over 4. And if you wanted to simplify, that would be your final answer. So we're going to jump over to this rubric real fast and call it a day really soon. They gave you a point for figuring out how to get that area. So that would be the very first thing we did, writing the statement and using those integral properties. So that was your first point. They wrote it in a little bit of a different way, but that's fine. They gave you a point if you could get the area from -2 to 5. So that would be this part. If they could see you demonstrating that, then they gave a point. And then the final point was for the answer. And again, you could either leave it in the unsimplified form, like we said, or simplify to the very end. So this question had a lot of tricky areas in it. I do think that first part, maybe that's something that we could get for sure, and then also try for the areas as well.